we're going to have a little look at adding and subtracting fractions. If we have a look at this first question, we've got two fractions with the same denominator, so immediately you know that this is a nice simple question because my denominators are already the same. And when your denominators are already the same, you do not have to go on the hunt to find equivalent fractions. You can simply take away the numerators. So 9 take away 4, we know it leaves us with 5, and our denominators can stay the same. So when we see questions like that, make sure you're being diligent, make sure you're looking at your denominators, because I know some people will forget that when we see same denominators, we don't have to do anything to change them, but we'll still try and find equivalent fractions and make the problem more difficult than what it needs to be. So stay diligent. When you see two denominators of the same number, you think, phew, all I've got to do is a simple takeaway and the denominator stays the same. Again, another question like this, you count in your lucky stars because you've got two denominators that are the same, so you know your denominator will remain as 6. And all you've got to do is 4 and add the 3, which leaves you with 7. Perfect. So moving on, we're going to look at fractions with different denominators. So we've got 3/4 take away 3/8. Now this time your denominators aren't the same. You've got 4 and 8. So your next job is to try and find a common multiple of 4 and 8, the lowest common multiple. So you want to find the lowest common multiple of 4 and 8. So you are able to find the same denominators. So you're making equivalent fractions. Now 4 and 8 we should be able to look at and know that 8 is a multiple of 8 and 8 is a multiple of 4. Because what I do to 4, I times 4 by 2. And whatever I do to the bottom of my fraction, I must do to the top. So I have to times my numerator by 2 also, which leaves me with 6. Now I have done nothing to this denominator, it has remained the same, so I don't have to do anything to my numerator. So then my problem then becomes 6/8 take away 3/8, which of course leaves me with 3/8. Now we should know that 3/4 is equivalent to 6/8. It means the same thing as long as you do the same thing to the bottom as you do the top. So we've times the 4 by 2 and the 3 by 2 to get our new denominator and our new numerator. Now this is a nice simple question because we should know our 4s and our 8 times table. And of course we're looking for the lowest common multiple. If you were given numbers where you think, ooh, I'm not too sure, we could just simply start writing out our times tables. So I've got 4, 8, there's that 8, I don't have to go on, and 1 times 8 is 8. So the lowest common multiple of 4 and 8 is 8. Let's look at this question again. We've got 4 and 8. I know that 8 is a multiple of 4. So 7/8 can remain the same. Now 3/4, I'm going to find an equivalent fraction for that. So 3/4, you ask yourself, equals how many 8s? I know that I've times my 4 by 2, because 2 times 4 is 8. So I know that I am going to times my 3 by 2, which equals 6. So my question now is 6 eighths, add 7 eighths, which of course leaves me with 13 eighths. Now, when we get a question like this, luckily 13 eighths is an improper fraction. It could remain as an improper fraction. However, we could also change it to a mixed number. And to change an improper fraction to a mixed number, we simply divide the top by the bottom. So 8 fits into 13 one whole time. My denominator always stays the same, and my remainder will go on top. So 8, 9, 10, 11, 12, 13. So I add 5 onto 8 to make 13, so 5 is my remainder. So we could have 1 and 5 eighths. It's particularly important if you get an improper fraction that when you change it to a mixed number, it doesn't make a whole. Because if you've got an improper fraction that when simplified creates a whole number, you wouldn't get the mark for leaving an improper fraction. So just be careful. Now this is where it gets a little bit trickier, but luckily on first glance I've got two denominators that are the same. When I get a question like this, if the two denominators are the same, I can work in two separate entities. So I can do 3, take away 1, which equals 2. And then I can work with my fractions. So I know 5 sixths, take away 1 6 leaves me with 4 6. So then I'm left with 2 and 4. Please excuse the 4. 2 and 4 sixths. So relatively easy question because I've got two denominators that are the same. Again, two denominators are the same, so a nice easy question. So I can work with 2, add 3, my two whole numbers, equals 5. And my two fractions add together, 1/5 add 2/5, leaves me with 3/5. A lovely question. Okay, so looking at a slightly more challenging question. So I've got here two fractions, the denominators aren't the same, and I've got a mixed number. Now I'm firstly going to work with my mixed number because I don't want to leave it as a mixed number. So to change my mixed number into an improper fraction, I'm going to go 2, the whole number, times the denominator, which equals 6. And then I'm going to do 6, add the numerator of 1 equals 7. So I've now got 7 over 3, as my denominator always stays the same, add 5 over 6. Now before I add them up, I of course need my denominators to be the same. I need to find equivalent fractions, and to find that I must find the lowest common multiple. Now luckily we've got two smaller numbers. If there were bigger numbers, I could simply start my times tables. So I could go 3, 6. I know 2 times 3 is 6. I know 1 times 6 is 6. So I can stop there. My common denominator is 6. So 5, 6 can stay the same. Nothing needs to be done there. It is 7/3 that needs to be changed into something over 6. And I know that 3 times by 2 equals 6. So I know that with my 7, I must do what I've done to the bottom to the top. So 7 times by 2 is 14. And now that I've got my two fractions with the same denominator, I can add up. So my 6 remains the same, and 14 add 5 is 19. I can leave that as an improper fraction because I know that 19 divided by 6 would not leave me with a whole number. Okay, if we have a look at this question, we've got a reasoning style question where you are asked to work with fractions. So we've got, this is a diagram of a vegetable garden. It shows the fractions of the garden planted with potatoes and cabbages. The remaining area is planted with carrots. What fraction of the garden is planted with carrots? So have a little think in your head. What's the first step we need to do with a question like this? Okay, so the question is asking us, what is left? What is left of the garden that we can plant it with carrots? We're given these two amounts here. So the first thing we need to do is add 2/3 and 1/4. Now, the first thing that comes to my head is these two denominators are not the same. I need to find the lowest common multiple of 3 and 4. Now, that might not just pop to my head. So I'm going to start my times tables. I've got 3, 6, 9, 12. I'm going to stop there because 12 is an even number. I know maybe 4 is an even number, so I might start my 4s. I'm going to go 4, 8, and 12. I'm going to stop there because I've got 2 same numbers. So 12 must be my common denominator. So I now need to find my equivalent fractions, and I'm remembering the rule, whatever I do to the bottom of my fractions, I must do to the top. So if I times my denominator 4 by 3 to get 12, I must times the top by 3, which gives me 3. Similarly, I've times my 3 by 4 to find my common multiple. So I need to times my 2 by 4, which gives me 8. And I know that 8/12 add 3/12 leaves me with 11/12. So far, 11/12 of the garden has been taken up by potatoes and cabbages. So the question is asking us, how many is planted with carrots? What was left for carrots? So we know that the whole garden in 12ths, if it was the whole garden, it would be 12/12, because 12/12 would be whole. We've used 11/12 so far. So we could work out 12/12 take away 11/12 equals 1/12. So there is our answer. What fraction of the garden is planted with carrots? Well, we are left with 1/12. Okay, we've got another reasoning style question. So we've got in the circle 1/4 and 1/6 are shaded. What fraction of the circle is not shaded? So I know that I've got to do a bit of an addition and a subtraction, as it is a 2-mark question, so I've got 2 steps to do. So the first thing I'm going to do is add up this section and this section. So I'm going to do 1/4 add 1/6. Now I am going to look for the lowest common multiple. Or what I could do, which some of you may know, is the butterfly method, which simply asks us to times our 2 denominators. So I've got 6 times by 4, which is 24. So I'll do 4 times by 6, which is 24. And of course, what I've done to the bottom, I must do to the top. So I'm going to do 1 times by 4, which is 4. And 1 times by 6, which is 6. Whether you use the butterfly method or you are competent enough to know your times tables and to just be able to know which is the lowest common multiple, both would get you the answer. So if you find it easier to use a butterfly method, go for it. If you know your times tables very well, just find the lowest common multiple. But remember the rule, whatever you do to the bottom, you must do to the top. So once I've done that, I know that 6 24ths add 4 24ths is 10 24ths. So far 10 24ths have been shaded. However, they are asking me what has not been shaded. So again, I know that the whole circle would be 24 24ths. So far, 10 24ths have been shaded. So what is left, we will do a take away. Or what is not shaded, we'll do 24, take away 10, which equals 14. And I know my denominator stays the same. If I was to simplify that, I know the top and bottom are divisible by 2. Because 2 is a factor of 14 and 24. So I know that 24 divided by 2 is 12. And 14 divided by 2 is 7. Now, unless you're asked, that step is not necessary. However, if you had worked this out at home and you had just found the lowest common multiple first, your answer would have been 7 over 12. And we know that 14 over 24 and 7 12ths are equivalent.